Lesson 19, Scientific Notation. Here's part 1. Evaluate. Here's box A. 8.3 times 10 to the third power, and we're going to write it using standard notation. This exponent of 3 tells you to move the decimal point 3 places to the right. Here's the decimal point, but so far we only have 1 place value to the right, so we need to add 2 more zeros. So our final answer will be 8,300. Letter B. 7.2 times 10 to the fifth. The exponent of 5 tells you to move this decimal point 5 places to the right. We only have 1 decimal place to the right, so we need to add 4 more zeros. Final answer, 720,000. Here's letter C. 3.35 times 10 to the sixth. And the exponent of 6 tells you to move this decimal point 6 places to the right. We only have 2 decimal places to the right, so we need to add 4 more zeros. Final answer, 3,350,000. Here's box D. 4.2623 times 10 to the third power. The exponent of 3 tells you to move this decimal point 3 places to the right. So we're going to go 1, 2, 3 places to the right, and our final answer will be 4,262.3. Let's just double check that answer. The exponent of 3 tells you to move the decimal point 3 places to the right. So look between the old decimal point and the new decimal point, and make sure that there are 1, 2, 3 place values. Here's part 2. Evaluate. All of these problems contain negative exponents. Take a look at box I. 1.23 times 10 to the negative second power. And this exponent of negative 2 tells us to move this decimal point 2 places to the left. We only have 1 digit to the left, so we need to add 1 more zero. Now we can move the decimal point 2 places to the left. 1, 2. And this is where the new decimal point will be. I'm going to add a leading 0 in front of this. So our final answer is 0.0123. Here's box J. 6.5 times 10 to the negative fifth power. And this exponent of negative 5 tells us to move this decimal point 5 places to the left. We only have 1 digit to the left, so we need to add 4 more zeros. And now we can move this decimal point 1, 2, 3, 4, 5 decimal places to the left. I'm going to add a leading 0 in front of it. So our final answer is 0.000065. Part 3. Write in scientific notation. Remember, target your new decimal point first. Box M. 1,350. Here's the old decimal point. Target the new one first. It'll go right here. Count how many places to the old decimal point. It's 1, 2, 3 spaces. So our final answer is 1.35 times 10 to the third power. Let's take a closer look to verify that. Count the digits between the new decimal point and the old decimal point. We have 1, 2, 3 digits, and that matches our exponent here. Here's box Q. 0.135, or 135 thousandths. Here's the old decimal point. Target the new decimal point. Where will it go? It'll go right here. Count how many places to get to the old decimal point, and that's 1 space to the left. And remember, that's like going to the negative side of a number line. So our final answer will be 1.35 times 10 to the negative first power. Part 4. Write in scientific notation. Target your new decimal point first. Here's box U. 275,000. Here's your old decimal point. Target your new decimal point, and it'll go right here. I'm just going to count the digits between the new decimal point and the old decimal point. I have 1, 2, 3, 4, 5 digits. So my final answer will be 2.75 times 10 to the 5th power. Once again, here are 1, 2, 3, 4, 5 digits. Box Y. 0.509 or 509 thousandths. Here's your old decimal point. Target the new one. It'll go right here. Count how many places to get to the old decimal point, and it's one place value to the left. Remember, that'll be the negative direction. So our final answer will be 5.09 times 10 to the negative first power.